Okay, now that we've described what the problem is and how close are we getting to solving the problem, now we need to know how to solve it, how to minimize the loss values. For that, we need something what we call an optimizer. And oftentimes, the optimizer that we will use belongs to a family called the stochastic gradient descent. They are they are a collection of iterative algorithms that train in a network of steps. So one step of the training can go like this. You sample a subset of the training data and run it through the network to make predictions. You measure the loss between the predictions and the true predicted values. And finally, you adjust the weights in a direction to make the loss smaller. So you just do this over and over and over again until you get to a loss value that is as small as you can get to. So to visualize this, we can see how this neural network is training itself using the stochastic gradient descent. So this linear line over here of the is the output of the deep learning algorithm, and all of these dark red dots are the mini batches or the samples of training data that is currently being used to adjust the weights of this deep learning algorithm. So as you can see, as it transitions to one mini batch to another, it also changes its weight as it goes along, and that will in effect change the outputs, and in effect that will theoretically reduce the training loss. So as you can see, as more and more mini batches it goes through and more epochs or a complete round of the whole training data is went through, the loss just gets smaller and smaller, and you get closer and closer to the optimum weights of the deep learning algorithm. So this animation shows how the linear model from lesson 1 is being trained with SGD, and every time SGD sees a new mini batch, it will shift the weights, meaning the W, or the W, the slope, or B, the y-intercept or the bias. And so eventually we come to know we can also adjust its learning rate and the batch size. So the learning rate is basically how big the shift will be after each learning period. So after you have decided that your loss needs to be lower by changing the weight, how much do you change the weight by? That is determined by the learning rate, and the batch size is really the size of the mini batches, how big of the subset of the training data should you use in each learning period. And these two parameters are often the two parameters that affect or just the SGD, how the SGD training will proceed, and their interaction is often subtle, and the right choice for these parameters isn't always obvious. But we can explore how we can experiment with these two parameters to lead to the optimum weights and of course the outputs. So fortunately, for most of the work, it won't be necessary to do an extensive search to find out the optimum learning rate and batch size. We can use something that someone else has created for us, and an example of this will be Adam. So Adam is an SGD algorithm that basically trains itself and tunes itself. It has an adaptive learning rate that makes it suitable to for most problems without any parameter tuning, and as a result, it is a good general purpose optimizer. So how do we add the loss in the optimizer to the deep learning model? We just add it onto the compile function inside the model. So after defining the model, you can add a loss function and an optimizer using the model's compile method. And just to note, you need to specify both the loss and the optimizer with just a string.